Good afternoon, dear students. Today we shall proceed with the next part in the file concept, that is a file system implementation. In the case of the file system implementation, we are supposed to focus on the concept more on the secondary storage. In previous discussion, we talked about the types of the files, attributes associated to files, and how we can access the files, what are the different operations that we can perform onto the files. Now today we shall see how the space is allocated to the files and what are the different ways by which it is considered for implementation. Now files are basically collection of related information which we are already known. File system is one which is permanently storing residing on the what we can call as an secondary storage, which is designed to hold large amount of data permanently. So disk which basically I must say provides a bulk of secondary storage which the file is basically maintained. There are two characteristics make them convenient medium for the storage of the multiple files. One is they can be rewritten at any given point in time. Another one is they can be accessed directly. So file system implementation is a very important and quite seems to be essential aspect. As we know already, operating system implements open and close system calls for the process request access the file content. Whenever file contents are requested for access, there is a open and close. When open and close is performed, then other related aspect related to the file has been effectively maintained. So this diagram is talking about the virtual file system, how the things are being effectively considered for the implementation. Now, when I talk about the disk structure, coming to the another important aspect, it consists of certain operations in memory structure where the implementation of the file system is considered. Some general principles apply. When we talk about on-disk file system may contain information about how to boot an operating system, how to store it, and what are the total number of blocks that are required, number of free blocks that are available. So these are all the basic information that are essentially required for the file system. Disk structure basically, as I mean, here is it contains two different aspects. One is boot control block and another one is file control block. Boot control block, you have already heard about one term called as a process control block, if you remember. Now we come to the that contains all information regarding the process. Now we talk about the boot control and the file control. Boot control block is one which contains information required by the system to the boot an operating system from that particular partition. From whichever partition it will be booted, so that information is required. If the disk does not contain any operating system, then this block can be certainly empty. That is another thing which you are supposed to know regarding this. And it is the typically first block normally of the partition in the user file system called as a boot block. And network file system, it is a partition boot sector, that is in general term. So the partition control block normally contains, if you look at the detailed part of the boot control block, partition control block basically contains the partition details such as the number of the blocks and the partition size of the block, free block count, free block pointers. So there are different aspects related to that particular block control is considered for the same. Now when I come to the file control block, in this particular diagram on the screen you can file. The file control block contains file permissions. File permissions, you are already aware of it. We talked about the read, write, execute permissions. File data I mean creation of the file, who is accessing when it is last written. File owner in the sense creator of the file, whether it is a group or along with its access control. Then file size is also mentioned, wherein size of the typical file, which is a file data blocks, how many blocks it has occupied in the particular given scenario is being considered for the now same. Next, we talk to the another important aspect in this particular chapter essentially is is directory implementation. Directory can be implemented as a linear list or a hash table. Okay, linear list in the sense linear list is, as you are already aware of, directory entries are required to the linear search for finding a file. So sequentially we just go on searching the entry, new entry are added at the end, and then it is searched directly. When it comes with respect to hash table, in hash method, linear list is stored as a directory entry. But however, hash data structure is also used, which will be computing normally from the file name and returns the pointer which is directly accessed. So I don't want to much more talk on the hash implementation. My focus is just on how it is implemented. Now we move on to the another important aspect called as an allocation method. How the disk space is allocated to the files. How the disk space is allocated. So there are three different ways. One is contiguous method, another one is linked allocation, another one is indexed allocation. On the screen you will find the diagram that explains the contiguous allocation. So this is a disk which we have drawn as a virtually taken from the Galvin book, and these are all serial number 0, 1, 2, 3 are nothing but the blocks. Now when we talk about the contiguous allocation, now one table is prepared which will show file name, starting address of that particular block, and the length of that particular block which is occupied by the particular file. Say file name count, whose starting address is 0 here, and it will have a length 2. So 0 and 1 are occupied by file name called as a count. The next second file name is mail, which starts from block number 6, whose length is 4. 6, 7, 8 and 9. So we have 4 different blocks with contiguous. The term contiguous matters more. So what this method mean here is, in this particular method, a focus is made on allocating the blocks to a particular file in a contiguous manner onto a disk. So if file requires 4 different blocks, so all 4 blocks are contiguously allocated. So what we call it in generally is, so when we make it more generalized, if B is the beginning of any block, the next will be B plus 1. So it is easy and head movement. That is B plus 1, B plus 2, B plus 3 and so on up to B into n minus 1. Why B plus n minus 1? Because it starts with the 0. Our allocation starts with the 0, so it is n minus 1. So accessing the file is easy. So if the first block B plus 1, if the first block is allocated, then which will be next one? B plus 1. Similarly, it is quite convenient to access them, and then it is quite easy to free also, because they are allocated contiguously. That is a main advantage, and that is how it functions. Now it has its own disadvantage as well. It results into the external fragmentation. What is an external fragmentation? Say consider that if you take up this example, file number, some file has taken 2 blocks 8 and 9, 6, 7, 8 and 9. Now 10, 11 are left free, and directly 12 block number starts with the what we call it as a file name called as a list. Now 12 to 3, that is 12, 13, 14. Now block number 15 is unused, block number 10 and 11 are unused. Now see, in this particular structure, total number of blocks freely available are 10, 11 and 15, 3. If any new file required 3 blocks, but it cannot be allocated here because it is contiguously not available. Here of course we can allocate it. Say for example here 1, 2, 3, 4. You take up this. So here we have 4 blocks available contiguously, 1, 2, 3, 4. Now my point here is, if any new file comes into the picture which require 5 blocks to be allocated. Now 1, 2, 3, 4 are available. 5th block cannot be occupied because cannot be allotted because it is occupied by another file. Now here, so totally 1, 2, 3, 4, 5, 6, 7 blocks are available in this particular entire scenario. But however, no contiguous 5 blocks are available. Hence, allocation is difficult. So this is a problem with the contiguous allocation. That is, in simple words, I call it as an external fragmentation. Now this problem can be solved using what I call as linked allocation. What the linked allocation will do here is, it will give you the starting of the name of the file name, then followed by end of that particular link. Say file, his name is a jeep, starts with the ninth block. So here, then it proceeds with the 4, 1, 6, 10. Finally, it ends up at 14. So it will give you the start and end. So because each block contains the address of the next block where the information is available. So as you know, implementation of the linked list. So each block certainly contains address of the next block. So continuously it will track where the next information is to be read. So I read it. This solves the problem of contiguous allocation, wherein external fragmentation is a major issue. However, so it does not require. So how it solves the problem here is memory not blocks not necessarily to be contiguous. Here they are scattered somewhere in and around, and still allocation can be done successfully. But the problem with the linked allocation is if the link of any particular block is lost, so certainly entire file tracking becomes difficult. And now to overcome this problem, there is a one more solution appears, is called as an indexed allocation. What the indexed allocation does here is it will make a one particular block. That block contains all the information of the links concerned to that particular file. See, file number block number 12 is corresponding to one particular file called as a jeep, and that contains whose address is 712, that is an index. So this will have list of all the blocks to which this file is connected to, that is called as a jeep. So it will maintain one index containing all the pointers corresponding to that particular block called as an indexed allocation. Fine. Now, so these are the three important implementations which are essentially required to know. Now, after considering all the allocation methods, that is contiguous, linked, and indexed allocation, now we shall move on to the last part of this particular module called as a free space management. Because students, you know that disk space is very limited. It is essential to reuse. We cannot create the space. However, in other words, I can say we can create the space by deleting the unused part of our storage part. So since disk space is limited, it is essential to reuse the space from the deleted files for the new files. So in order to keep track of that free space, so system maintains a separate free space list wherein it contains all free space. Another one is all used spaces. Whenever file is deleted, so its space is given to the free space back, wherein it will be considered for the usage purpose. And next time whenever anything new space is to be allocated, the operating system will get it from that particular free space list, which we call it as. Now this list records all the free disk blocks, that is what I mean, which are not allocated to the any file or the directory. When file is to be created, as I mentioned, a required amount of space is been allocated, and then it is. So how this free space is maintained is, one parameter is bit vector. Here what happens here is for each block, as many number of blocks are there, so many bits are set. So for each block, a bit is set to either 1 or 0. If block is already allocated, it is set to 0. If block is free, it is set to 1. Well, let us take up an example here. Say consider that block number 2, 3, 4, 5, 8 are free. Then it is represented, see, starts with the 0. 0th block is occupied. First block is occupied. Block number 2, see, observe on the list. Block number 2 is free. So this is block number 2, free. Block number 3 is also free. 4 is free. 5 is free. Fine. And then 6, 7 are again occupied here. 6 is not there. After 5 we have 8. Then 8th block is free. So in this way, in terms of zeros and ones, it maintains the list of the free blocks as and when it requires to be accessed. Then finally you come to the linked list. Linked list is like a linked list allocation of that particular file allocation, which we have already seen. This approach links together all the free disk blocks by keeping pointer to the first free block. As usual, pointer is always, linked list talks about the pointer, and pointer is always pointing to the first, then it maintains the subsequent link in the special location of the disk. So with that we conclude the module number 4. I will send the notes the same way. So in next class we shall discuss on the last module, that is module number 5. Thank you.